So 6.1 is the last bit of our trig functions because we did chapter 4, chapter 5, so this is the last one, chapter 6. And then we're going back to transforming like log equations and exponential equations. Okay, so the reciprocal identities and the quotient identities, those are something you're going to want to not remember necessarily, but know how to work them. Okay, they go on your formula sheet, so you'll get them, so you don't have to memorize them, but you have to have an understanding of what they mean. Okay, so the reciprocal identities, they're just saying that okay, so cosecant, the opposite is sine. Okay, so if you have sine, you can say that's 1 over cosecant, or if you have cosecant, it's 1 over sine. Those are reciprocal functions, meaning they're opposites. Secant, the opposite of that is tan, or sorry, cos. So it's 1 over cos x. So if you had cos, you could say that's 1 over secant also. And then the opposite of cotangent is tan. Okay, so those are our reciprocal functions. And then quotient identities, one of these we already talked about earlier in the topic. We said that tan is the same thing as sine over cos. We talked about that on the unit circle so that we could figure out what points tan were on the unit circle. So tan is when you take whatever sine is, you put it over whatever cos is. So, whoops, sorry, I forgot an end there. So then cotangent, since it's always the opposite of tan, then it would be cos over sine, because it would be the reciprocal of it, the flip. Okay, so example 1 is saying we want to verify a potential identity, numerical and graphically. So it says determine the non-permissible values. So again, this non-permissible values is just saying you can't have things equal to 0. So then we have to see where on our unit circle do these things equal 0, and then we say they can't equal that. Okay, so what we do is we look at each piece of the equation. So the equation we're looking at is this equation. So I'm going to look at each piece of this. Okay, so secant is the same thing as 1 over cos, right? Secant's the same thing as 1 over cos. So we can't have cos equal to 0. So if we were looking on our unit circle, we'd look and see where does cos equal 0. And if we were looking on our unit circle, we'd see that it equals to 0 at 90, and then at 270, and then if you just kept going round, round, round. Okay, so we write that as 90 plus 180 n. All it's saying is you're at 90 and then plus 180, and then n is how many times you just keep going. Okay, because it went from 90 to 270. Okay, so 90 to 270, the difference between that is 180. Okay, that's where I got the 180 from. Okay, so then if we were looking at tan, where is tan undefined? Well, we talked about tan graphs, right? And we said they were undefined at that dotted line when we drew it. And that dotted line was at 90 degrees usually, because it was halfway between the period length. And then if we kept going, it would be at 270. Okay, so again, this has the same non-permissible values as the cos one does. So we can write it as 90 plus 180 n, just to simplify it. Meaning if we kept going and going, increasing our n's, it would just increase the degrees. And then we need to look at our sine piece, okay? So where is sine equal to 0 on our unit circle? And it's equal to 0 at 0 and at 180. Okay, so we could represent that as 180n, right? Because it's just increasing by 180 every time. Okay, and so now if we wanted to put all these three together, these two are the same, and then this increases at 180n. So this looks like it's going 0, 90, 180, 270. Okay, and it just keeps going every 90. Okay, so we can write it as the non-permissible value is 90 degrees n. I'll put permissible. Because for sine it can't be 0, and then cos it can't be 90, and then sine it can't be 180, and cos and tan it can't be 270. So that's increasing every 90, so you just say 90n. So if n was 1, it would be 90. If n was 2, it would be 180. And you just keep going. So these are going up by 90s. So that would be our non-permissible value. And then it says, numerically verify that 60 degrees and a quarter are solutions of the equation. Okay, question B says, numerically verify that 60 degrees and pi over 4, so quarter pi, are solutions of the equation. Okay, so our equation, again, was secant x is equal to, was it tan over sine? Okay, so we're going to look at these as a left side, and then we're going to look at them as a right side. So we'll keep them separate, okay? So secant is on the left side. And so say we're trying to verify it for 60 degrees. So if we said secant 60 degrees, secant 60 degrees, secant doesn't show up on the unit circle, so we try not to talk about it, right? We'll talk about it as cos. And secant is 1 over cos. So we'll be talking about where is cos 60 degrees, like what point is that? So you would need to look at your unit circle, and you would notice that cos is 60 degrees at a half. Okay? So we can write that as 1 over 1/2. And so now we have a fraction over a fraction. So whenever we have the fraction in the bottom, we multiply by the reciprocal to get rid of it. Okay, so in the bottom it crosses off, right? And now we just have 1 times 2 over 1. 2 over 1 is just 2. So we have 1 times 2, so we end up with 2. So we're saying that secant 60 is equal to 2. So it's going to be a solution if the other side equals 2 also. Okay, because we're saying that secant is equal to tan over sine, so they both have to equal the same thing when we solve them. So we'll sub in the degree, so we'll say tan 60 over sine 60. Okay, and we know that tan is sine over cos, right? So we'd actually have sine 60 over cos 60 over sine 60. Right? So all I did was switch my tan into sine over cos. Okay, because tan is the same thing as sine over cos. Okay, so imagine this as sine over cos, or sine 60 over 1. So we'll multiply by the reciprocal because we don't like having fractions and fractions. So we'll go sine over 60 here. So that these will cross off, and I'll be multiplying by 1 over sine 60 in the top also. Okay, so now our whole bottom's crossed off, and we can cross off our sine 60s. So I end up with 1 over cos 60. And if you notice on our left side, we had 1 over cos 60, and we found that to be 2. So this should also be 2. So then that means that 60 verifies the solution, that these are equal. Okay, so the pi over quarter piece would be done exactly the same, except instead of having 60 degrees, you would just put pi over quarter in, and you would solve it. So we'll just move to C. And C says, use technology to graphically decide whether the equation could be an identity over the domain. Okay, so, sorry. We're not going to use the graphing calculator. I'm going to show you how to do an identity just by solving it. So what we're going to do is we're just going to prove that, oops, our equation was tan over sine, right? We're going to prove that those two things are equal. Okay, so usually when we're doing an identity, you leave the easy side or the simpler side, and then you try to make the other side look like the simpler side. So we're going to leave secant how it is for now. And we're just going to, sorry, I shouldn't have put equals. We're just going to work on the right side just to try to get secant. Okay, so we're going to try to make our right side look exactly like our left side. Okay, so tan, what can we change tan to? Sine over cos. Okay. So we have sine over cos over sine. Okay, and so remember, that's kind of like having sine over 1. So if we want to get rid of these fractions, we can times by 1 over sine. Okay, so the bottoms will cross off, and then we can cross our sine that's in the top and in the bottom off. So what we're left with is 1 over cos. And what is 1 over cos? It's secant. So now we proved that this side and this side match. Okay, so example 2 says determine the non-permissible values of this equation. Okay, so here's our equation. So we got to look at every piece and say that we don't want it to equal to 0. So where does it equal 0? So if we're looking at cotangent, cotangent is 1 over tan. And if we're looking at our unit circles, cotangent, oh, it would be like the opposite of what tan is, right? So if we were thinking about our equations that we drew, it was non-permissible when it was tan at half pi, right? And then we drew our pictures on the period length, which was pi. So now since it's cotangent, you would say it can't equal pi, okay, because it's a reciprocal of it. So we can't have x equal to pi, and then we need to look at the bottom piece here, where cosecant x and cos x, they can't equal 0. Okay, so where does cos equal 0 on your unit circle? It equals it at half pi, which is 1, I think, on the... So if we're looking at this, we're saying it can't equal a half pi, and it can't equal pi. So every half pi, right, half pi, pi, 1.5 pi, 2 pi, that's where we're going to have it undefined. So just to summarize it, we'd say the non-permissible value is half, or pi over 2n, meaning whatever n is, then those values increase for a non-permissible value. So it could be a half, it could be a full pi, it could be 1.5 pi, 2 pi, going up by halves. Well, as long as you kind of made like ... like, because it would have to mean it keeps going no matter what. Okay. So now if we were going to simplify this, simplifying just means we're going to make it as easy as we possibly can make it. So that's kind of like what we did for C on example 1. So we're just going to try to break this down. So is there anything that we can write cotangent as instead of cotangent? What? 1 over tan. Okay, but if you notice, we don't really have any tans in the bottom here. It's cos over sine is the sine thing as cotangent, right? Because tan is sine over cos. So we'll write it as cos over sine. Okay, and if we would have had a tan somewhere in the bottom here, I probably would have went with the 1 over tan. But since we don't, and these look more like coses and sine stuff, then we'll stick with cos and sine. Okay, so cos over over sine is cotangent. And then can we simplify cosecant? What's that? 1 over sine. And that's multiplying to the cos in the bottom. Okay, so if we were to simplify that bottom, here I'll just separate this. If we were simplifying the bottom, our top is still cos over sine. And now our bottom is 1 over sine times cos, which is cos over sine, because 1 times cos is cos. And you can imagine that cos is over 1. So 1 times cos is cos, 1 times sine is sine. So now we have cos over sine equals cos over sine, which equals what? 1. Because if we had 4 over 4, it would be 1. So cos over sine over cos over sine is 1. So that would be our simplified expression. Okay, so on our last page of our notes, we have Pythagorean identities. So they're saying that if you had cos squared plus sine squared, that's equal to 1. And if you had cotangent squared plus 1, it's equal to cosecant squared. And if you had 1 plus tan squared, that's the same thing as secant squared. So you might want to star those. You get them on your formula sheet. You just got to know how to use them. Okay, so it says, example 3, verify that the equation cos squared x plus 1 is equal to cosecant squared x. So they're just saying, basically, prove that is true, right? Because they told us in our formulas that that's the case, but we're going to make sure that it's right. Okay, so, and they said use pi over 6. Okay, so if I, oh sorry, this is supposed to be cotangent, right? Okay, so instead of having my x value in there, I'm just going to put the pi over 6 that they want us to test out. Okay, so cotangent squared, we can write that as 1 over tan squared, because if cot is 1 over tan, then cot squared is 1 over tan squared. So we can write it as 1 over tan squared with our pi over 6. And I'm just going to split these so we have a left and a right side. Okay, if we were doing our unit circle and we wanted to know what pi over 6 was for tan, we'd have to find out what it was for sine and then cos. And so if we did that, we would find that it was 1 over root 3. So we're just going to replace our tan squared with 1 over root 3 squared. And we still have this 1 on the top, and we still have a 1 there. So I'm going to get this fraction out of the bottom. So if I multiply by root 3 over 1, root 3 over 1 squared technically, because it's still squared, we're going to end up with root 3 squared in the top, because these guys will cancel. And we still have this plus 1 along the side. Okay, and so root 3 squared is like root 9, which is 3. So when you square a root, you're essentially just canceling the root. So you have 3, whoops, that's supposed to be a 3. So we have 3 plus 1, so our answer on this side is 4. Okay, and if we were going to work through this other side, this cosecant squared pi over 6, cosecant is the same thing, cosecant squared is the same thing as 1 over sine squared pi over 6. So if we wanted to see what pi over 6 is, we'd look on the unit circle to see what sine is at pi over 6. And what we find is that sine is a half. So we have 1 over a half squared. Okay, so all I did was replace my pi over 6 sign with what that is on the unit circle, which is a half. So when we square that, we end up with 1 times 1 is 1, and 2 times 2 is 4. And we want to get our fraction out of the bottom, so we multiply by the reciprocal. And these guys cancel, and you have 4 over 1 times 1, which is 4. So that verifies that that is true, because we have 4 on the left side and 4 on the right side.